Okay, PreCal, this is the notes video for section 7.2 on ellipses and circles. The substitute should have passed out your note sheet that you're going to follow along with. Hopefully you turned in your 7.1 homework. If you didn't finish it, then you need to turn it in tomorrow for a late grade. Follow along as best you can. If you need to have the sub pause the video, then just ask politely. So the first few slides are not on your notes page because we already have this information in our foldable for conic sections. So you might want to get that foldable out if you don't already have it out. So first we're going to talk about ellipses, a vertical ellipse and a horizontal ellipse. So you're going to notice there's just a slight difference between the two different ellipses, between their equations, and that's the A and the B on the bottom of the equation. A vertical ellipse is longer up and down than it is left and right. The center is still going to be HK, and remember when you pull the HK out of the equation, it's going to change sign. An ellipse has two focus points, H, K plus or minus C. And if you notice, those focus points are always along the major axis. So if an ellipse is longer up and down, then the focus points are going to be up and down. When we look at a horizontal ellipse, the focus points are going to be left and right. The vertices are the 4 points on the outside edge of the ellipse. On here, they call them vertices and co-vertices, but most of the time I just say vertices. The major axis is x equals h, and minor axis is y equals k. And then on your foldable, we put some information for the eccentricity, and I put c equals the square root of a squared minus b squared to find c. You'll need that for your focus points. Okay, and then for the eccentricity, it's not on here, but I'll come back and talk about that in just a second. Okay, so next is a horizontal ellipse. So most of the information is the same. The focus points this time are left and right from the center. So this time you would add C to the H part of the center. You have information on the vertices and co-vertices. And we will find the eccentricity and the C value the same way for a horizontal ellipse. Okay, so all the eccentricity means, and there's a lot of extra information on this slide that I'm not going to talk about, but eccentricity is just how circular or stretched an ellipse is. So the closer it looks like a circle, or the more it looks like an oval. So we wrote down on our foldable that E equals C over A. So that number is always going to be between 0 and 1, and you'll see after we do a couple of examples how to find that value. Okay, circles are super easy. A circle at 0, 0, the equation is just x squared over r squared equals y squared over r squared equals 1. So the center is obviously at 0, 0, and then the radius is r. So you're going to take the square root of that number at the bottom to find the radius. The only difference for a circle at hk is it's x minus h all squared plus y minus k all squared. Both of those are over r squared. Okay? So let's start looking at some examples. So these are on your note sheet. Try to follow along as best you can. We're going to start with this equation that is a circle, x minus 2 all squared over 25 plus y plus 1 all squared over 25 equals 1. One thing you'll start to notice, other than the fact that in the instructions it kind of indicates that it's a circle, is in the denominator, if both of those numbers are the same value, then it has to be a circle. We're going to go the same direction, left, right, up, and down. So first, for the center, we're going to pull out the h and k from the parentheses. So our center is going to be located at 2, negative 1. So go ahead and plot your point 2, negative 1 on your graph. Then to get the radius, we need to take the square root of the number in the denominator. So the square root of 25 is 5. So this means we're going to go 5 in all directions. And it's just easier to go left, right, up and down 5 to plot those 4 points. Okay, then you can connect the dots. Don't be afraid if your circle kind of looks like a smushed square. Just draw the circle as best you can. It's easier if you go kind of point to point instead of thinking of the circle as a whole and kind of arc in between each of those points. So here's our circle located at 2, -1 with a radius of 5. Okay, example 2 says to identify the center, vertices, foci, eccentricity, and then graph. So with this information, I know that this is going to be an ellipse. I also know that it's going to be an ellipse because I look at the 2 numbers in the bottom and they are different. So that means I would go different amount of space left and right as I would up and down. So we're going to start with the center the same way as a circle. So we're going to pull out the HK. So this is going to be -3, 5. So I'm going to plot the point -3, 5. You can use the information on your foldable to find the A value and B, etc. But this is the rule that I always go by. So whatever number is underneath the X term, that's how many spaces I'm going to go left and right. Since it's under the X, I'm going to go left and right. And I'm going to take the square root of that number. So I'm going to take the square root of 16, and I'm going to go that many spaces left and right. So I'm going to go 4 spaces left and right from the center and put 2 points on there. And then whatever number is underneath Y, I'm going to take the square root of that number, and that's going to tell me how many spaces to go up and down, because Y is up and down. So I'll take the square root of 25, and I'm going to go 5 spaces up and down. So those are your vertices, and you're just going to connect those dots like you did your circle, but this is going to be more elongated. It's an ellipse. So it's longer up and down, so this would make this a vertical ellipse. Okay, so they may ask us for a few things about the ellipse. So let's write down what they ask us. We've already have our center. So next thing I need to do is find out how far away my focus points are. And we need to use the formula C equals the square root of A squared minus B squared. So here's where we're going to do C equals the square root of 25 minus 16. So 25 minus 16 is 9, and the square root of 9 is 3. So this tells me, the C value tells me how far away the focus point is from the center, and it's always along the major axis. So since our ellipse is longer up and down, then I'm going to go 3 spaces up and down from the center to get my focus points. Okay, so then when I write the ordered pairs, I can either use the equation in my foldable, or I can count the spaces, and I know I'm going to go 3 spaces up and 3 down from the center. So my focus points are located at -3, 8 and -3, 2. Okay, next I'm going to write out the vertices. So those are the 4 points that are on the edge of my ellipse. So the first one on the right hand side is at 1, 5. Then I'm going to go up to -3, 10, -3, 0, and -7, 5. Okay, so your 4 points on the edge of the ellipse are the vertices. And then the last thing we're going to find is the eccentricity, and eccentricity is just C over A. So since I already know C is 3, our A value was how much we went up and down on the major axis. So 3 over 5 is the eccentricity. And this just tells me how circular this ellipse is. Okay, so on examples 3 and 4, our equations are not in the correct form to graph, so we're going to have to do a little bit of work to get them there, and then we'll find out all the information that we did on the first 2 examples. So kind of like what we did with the parabolas, we have to group x's and y's together, and we're going to wind up completing the square for each set of x's and y's. So I'm going to go ahead and rewrite this and put all my x's first, then my y's, and I'm going to move any constant to the other side. So x squared minus 12x, and I'm going to go ahead and leave a space because I know I'm going to have to complete the square in a second. And then my y's, plus y squared plus 10y, and I'm going to leave a space, equals negative 12. Okay, so we have to complete the square to make this a perfect square on the top of the fraction that we're going to get to eventually, to make it look like our formula. So we do negative 12 divided by 2 and then squared. So negative 12 divided by 2 is negative 6, squared is positive 36. And remember, we have to add this number to both sides of the equation. I'm going to do the same thing for the y, so I'm going to do 10 divided by 2 squared. So 10 divided by 2 is 5, squared is 25. So now that I've completed the square for the x's and the y's, I'm going to rewrite both of those as a perfect square. And remember, when you're writing it, it's the number before I squared it. So for the x's, this is going to be x minus 6 all squared. For the y's, it's going to be y plus 5 all squared. And then I went ahead and added negative 12, 36, and 25, and that equals 49. Okay, so you notice in the formula that our equation equals 1. So all I have to do is divide 49 by everything, and I will get the 1 on the right-hand side. So x minus 6 all squared over 49 plus y plus 5 all squared over 49 equals 1. So now, just like example 1, I can find the center and the radius to graph this circle. So the center is going to be at 6, negative 5. And then I'm going to take the square root of the number in the denominator. So the square root of 49 is 7. So our radius is 7. So I'm going to plot the point 6, negative 5. And then I would go 7 in 4 directions. And our circle is going to be a little bit off the graph, so just make it work for you. So I went 7 up, 7 to the left, 7 down, and I'm pretending to go 7 to the right. And then I would connect those dots with a circle. So this is our circle that is located at 6, negative 5 with a radius of 7. Okay, so on example 4, we have a similar problem in that our equation is all multiplied out. It is not in the correct form that we need it in to find all the important information to graph. So I'm going to start the same way I did with the circle. I want to group the x's, group the y's, and the constant is going to go on the right-hand side. So we're going to have 3x squared plus 18x plus y squared minus 2y equals 8. Now if you notice on this one, I have a leading coefficient in front of the x squared. I have a 3 in front of there. And in order to complete the square, you can't have a constant in front of the x squared term. So I'm going to factor a 3 out just for the x's, okay? It would be the same thing for the y's. If there was a number in front of y squared, then I would factor that number out just for the y's. So I'm going to factor a 3 out of the x's. That's going to leave me with x squared plus 6x. And I'm going to go ahead and leave my blank so I can complete the square in a second. For the y's, there's not a number in front of y squared, so I don't have to do that. So I'm just going to go ahead and rewrite the y's and leave a blank. Equals 8. So now when I complete the square, I'm still going to do 6 divided by 2 squared, which is 9. But this time I didn't really add 9 to the equation. I really added 3 times 9 to this side of the equation. So you have to take into account the number that you factored out of that polynomial. So 3 times 9 is 27, so I'm going to have to add 27 to the other side. For the y's, negative 2 divided by 2 and then squared will be plus 1. Since I didn't factor a number out of the y's, then I don't have to multiply that by anything, so that's just plus 1. Okay, so now I can write these as perfect squares. The 3 is going to stay out front, and it's going to be x plus 3 all squared. Remember, it's the number before you squared it. And then for the y's, y minus 1 all squared. And then I'm going to add up those numbers on the right, and that equals 36. So now we're going to divide everything by 36 to get the 1 that we need on the right-hand side. So you notice for the x's, I have a 3 out front over 36. 3 over 36 is going to reduce, so that's going to be x plus 3 all squared over 12. For the y's, there's not a number in front of the parentheses, so that doesn't reduce, it stays. And then equal to 1 on the right-hand side. Okay, so now we're going to find all the fun information for our ellipse. So we're going to start with the center. The center is going to be at negative 3, 1. Okay, then we're going to need to take the square root of both of those numbers in the denominator to find out how far left and right and up and down we need to go to make our ellipse. So we start with the number underneath the x, and we need to take the square root of 12. That's going to tell me how far to go left and right. So the square root of 12 simplifies to 2 square root 3, which is approximately 3.46. It's always good to know about how much that is so that I can plot those points, but I still want the simplified radical as part of my answer there. So I'm going to go about 3.5 left and right. Same thing with the number underneath the y. That's going to tell us how far to go up and down. So the square root of 36 is 6, so I just go 6 spaces up and down. So again, this one is going to be a vertical ellipse because it's longer up and down. There are my 4 points for my vertices. We're going to come back in just a second and we'll write down what those vertices are. So next I need to find out how far away the focus points are. So C equals the square root of 36 minus 12, which is the square root of 24. The square root of 24 simplifies to 2 square root 6. I'm going to need that exact number in a second, but this is about 4.89. So what that means is, since it's longer up and down, I'm going to go about 4.9 spaces up and down to get my focus points. Okay, so pretty close to 5 spaces away. Okay, so we still need to write down our vertices and our focus points and then find the eccentricity. So I'm going to go on a new slide. I'm going to keep the graph here, but I'm going to have some space to write those things down. Okay, so we're going to start with the focus points since I just found out that those were 2 square root of 6 spaces away from the center. So since that went up and down from the center, we are going to add and subtract that number from the y coordinate of the center. So if you look at your formula, that will help you as well. The ordered pair, or one of the ordered pairs, would be negative 3, comma, 1 plus 2 square root of 6, and we're going to leave it just like that. And then the other one would be negative 3, comma, 1 minus 2 square root 6. Okay? Next, for the vertices, so since our we went left and right a strange number, approximately 3.46, we're going to go back to that simplified radical to write those vertice points. Okay, so I'm going to get the up and down ones first since they're whole numbers. Those would be at negative 3, 7, and -3, -5. For the left and right points, we went left and right from the center, what was it, 2 square root 3. So -3 plus 2 square root 3, comma 1, and then -3 minus 2 square root 3, comma 1. So I know those look a little strange because they still have the radicals in there, but we want the exact answer when we're writing. You can use the approximation when you're putting them on the graph. Okay, then last is the eccentricity. So remember, eccentricity is C over A. So this would be 2 square root of 6 over 6, since we went 6 spaces up and down from the center. And this would reduce to the square root of 6 over 3. Okay, the last two we're going to write the equation given some specific information. So on number 5, it says to write the equation of a circle. We're given the center is at -1, 7, and the diameter is 6. So I'm going to go ahead and put the equation of a circle up here. And we have the center, so that's good, but I need the radius in order to plug that into the circle. So remember that the diameter is twice the radius. So if I want the radius, I just divide by 2. So our radius is going to be 3. So when we plug in our center, remember they're going to change signs when we put them back in the parenthesis. So this is going to be x plus 1 all squared over, and we have to square our radius, so 3 squared is 9, plus y minus k all squared, so that's going to be y minus 7 all squared over 9 equals 1. Okay, last example, number 6, we're going to write the equation of this ellipse. We've been given some information on the graph. First thing is that the center is at -4, -6. I need to know how many spaces they went from the center, left and right, and how many spaces they went up and down to give me my A and B value that I need for my equation. So this graph is a little scaled differently. This doesn't go by ones, if you notice that. So if I want to look at the distance from the center to the point on the left-hand side, so that point on the left is located at -10, -6. -10, -6. So I need to know how much space is between the center and that point. So since our center is at -4, -6, then there has to be 6 spaces in between those. Same thing for vertically. If I look at that top point on the very top, that ordered pair would be -4, 6. So I want to know the distance from the center to that point, and that is 12 spaces. Okay, so 6 and 12 are the A and B values that I need to plug into my equation. So we're going to start with the x's. We're going to do x minus 4 all squared, or minus a -4, so that's going to make it be positive. And since we went 6 spaces left and right, that's the number that needs to go underneath the x's, but we're going to square it. So it's going to be 36. And then for the y's, y minus a -6 will become y plus 6 all squared. Then you take the number that you went up and down and square that number. So 12 squared is 144. And then we set it equal to 1. Okay, so you should be able to pick out the information for ellipses and circles or write the equations of those. Hopefully you got everything down. Use your foldable. It has a lot of good information in it. You should be able to start your assignment. I'll be in class tomorrow and we'll work on it in class and I'll answer questions.